Today, I'd like to introduce you a paper from the magazine Multimodal Transportation. It's called Investigating Tools for Evaluating Service and Improvement Opportunities on Bicycle Routes in Ohio, United States, whose first author is Kailai Wang. Besides, this is an article about bike route service and improvement. I hope you can learn something. Over the past 2 decades, transportation engineers and urban planners have become increasingly interested in using performance measures to capture roadway infrastructure effects on bicyclist comfort levels. In this study, a tool is developed for evaluating Ohio's local roads and identifying opportunities for improvement. This begins by assessing the available data sources required to develop a customized model for Ohio, United States. Stakeholder interviews and data assessment outcomes indicate that most local jurisdictions do not have access to all relevant data for a complete bicycle level of traffic stress analysis. Therefore, we extend the original bicycle LTS framework by formulating effective methods to deal with missing data. The design methods are based on Ohio's functional classification system and existing data on speed limits, traffic volumes, and bicycle facility widths. Our approach enables agencies to conduct bicycle LTS analysis when critical data elements are missing, such as posted speed limits, traffic volumes, and bicycle facility widths. For example, compared to the assignments with completed Mid-Ohio region data, the proposed approach reaches a 90% match in bicycle LTS score assignments in urban areas. When road traffic volumes are missing, local communities in Ohio and beyond can adopt the proposed approach to achieve interim and temporary results when collecting accurate data is not feasible due to time and cost considerations. Figure 1 shows the flow chart of the proposed framework. How bicycle LTS categories are determined under different road conditions. The paths marked with red dotted lines are 5 scenarios to obtain the interim results when the data availability problem occurs. 1. Knowing bicycle facility types or width of bike lanes only. 2. Knowing bicycle facility and parking facility types or the total width only. 3. Knowing lane number per direction only. 4. Knowing lane number per direction and speed limits, but missing traffic volumes. 5. Knowing lane number per direction and traffic volumes, but missing speed limits. The research process mainly includes 4 parts. The first section is the interim pathway to fill data gaps. This study proposed methods for inputting missing speed limit and ADT data based on functional classifications and Ohio-specific data, accounting for the differences between urban and rural contexts. The second part is model application in the Mid-Ohio region. In this study, a baseline road network was developed using the MORPC's Franklin County location-based response system centerlines. The third part is data processing. The information on ADT from ODOT TIMSI's layer was merged with MORPC's layer in the study. The fourth part is results and discussion. Using the bicycle LTS framework, most of the road segments in the analysis sample were assigned LTS 3 and LTS 4. The last part is an overview of the conclusion of this article. This study developed a bicycle LTS framework based on Ohio's data sources. Efforts within this project identified gaps in the bicycle LTS analysis for rural areas. However, the bicycle LTS framework can be refined to integrate a broader range of facility and rider characteristics. Additional opportunities for refining the bicycle LTS framework include assessing intersections and expanding the analysis of urban roadway conditions to include driveways and various curbside activities. This study also recommends testing how the outputs of a bicycle LTS analysis can be used to inform planning efforts.